So anyway, my name's Jim, for those of you who haven't met me before, and I've been using Omnis to connect to SQL databases since I first started using Omnis, which was back in Omnis 5. And I've sometimes maintained native Omnis data files, but I've never written one intentionally. And most of my work has been using Omnis connecting to mainframe databases or now smaller SQL compliant databases. Looking at today is the PET LBS and PET DF1. And we'll connect to PET DF1 through Omnis SQL. So you can see all the SQL stuff there. So once you have this up and running, the way I have this set up, which is more complicated than you're likely to do in a real application, but I have a bunch of different choices. So I can, at the same time, be connected to an open-based database and to an Omnis SQL database and to a front-based database, just so I can demonstrate the differences. So if I'm right here, I'm going to connect to open-based v3 connection. And this you can't do because you don't have open-based running on your machines. And it says I'm happily connected, but I'll also connect to Omnis SQL. And here when I say OK, it's going to prompt me for my data file. Found it. So what we're going to be looking at here, I'll just take you on a quick tour through the different windows. This window here, basically you're viewing one row of a table, and you can do next, 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 previous, previous, previous. You're just looking at data for a row. You can modify things here by taking away the Z's. You can do an update, you can do an insert, you can do a delete, and then when you're done you can say finished. The food window uses a smart list, because we're going to be talking about smart lists. So it works a little differently, and once we get into the smart list section, I'll explain what it's doing and how it works and how smart lists work. Basically, the short summary is a smart list allows you to build an interface where the user makes changes to multiple rows in an enterable grid, and then when they click on their save button, Omnis has stored information about which rows are new, which rows have been deleted, which rows have been updated, and it does the appropriate SQL for each one. Then when we get to this window, it's showing an example of a parent-child relationship. When I click on Antelope here, I see 4 children, and when I click on a child, I can see the record there. So it's just showing how a parent-child relationship works and how you code the SQL for that. Studio comes with this thing called SQL Browser built in. What you can see here are, I'm going to get rid of this session, and I'm going to close this library because we're not doing this now. And you've all seen this part of the window, but what the SQL Browser shows you here is my sessions that I've opened to different databases. I've logged on to 2 databases here, so I can see the sessions. If I drop it down, I see tables and views for this session. If I drop down the Omnis one, I just see tables, because there's no such thing as a view as an object that my open-based database has, but my Omnis database doesn't have. If I had a session open to an Oracle database, I'd see a number of other objects here as well. I'd see stored procedures, and I'd see functions, and I'd see triggers. So this is showing me Omnis's view of the database. Omnis has these things called DAMs, which stands for Data Access Manager, and that's how Omnis handles its connection to databases in a way that for the most part allows you in Omnis to not care what you're connected to. So there's a DAM for Oracle, and there's one for OpenBase, and there's one for FrontBase, there's one for Omnis SQL. There are also more generic ones. There's one for ODBC, and there's one, I forget, there's a JSQL DAM, I think. The DAM allows me to code SQL and interface with the SQL server in the Omnis side, not caring too much about specifically how different servers act. and the DAM will translate the same thing in the Omnis world to different things for Oracle or Postgres or MySQL. So that's the function of the DAM. It's this middleware, this middle layer between Omnis and the SQL Server. When I go click on SQL Browser, I can go into something called Session Manager, and let's just double click on one of these so you can take a look at it. What we see here is a definition of a session. This is my open-based session, and the parameters that you define here are going to be different depending on the database you're connecting to. Some require certain things, some others. They all require a name as anything I want to call it. That's just so I can identify it. Here's the DBMS vendor. It's only going to show a vendor if I have the external installed in Omnis. If I didn't have the Oracle external installed, I wouldn't see Oracle on this list. Then depending on what I select here, I might see different data access modules. So I can access an open-based database with any of these three DAMs. There's a specific open-based DAM, there's an ODBC DAM, or a JDBC DAM. ODBC and JDBC are both sort of more generic data connectivity tools that allow multiple front ends to connect to multiple back ends, as opposed to the Oracle DAM or the Postgres DAM, which are very specifically built just so Omnis can connect to Postgres or Omnis can connect to Oracle. So in my case, I want the open-based DAM. Sometimes there'll be an option for database version as well. If I'm using JDBC, I'll need a driver name. And then what you put in these fields is going to vary depending on what your database is that you're connecting to. With OpenBase, I need a host name, and in this case it's a database name at localhost. It's saying connect to a database right on this same machine, but it could be a database over a network as well. And then a username and a password. What was that? Can be an IP address. Yeah. And with OpenBase, it can actually be a port number and an IP address because you can have multiple servers running on different ports. So what we're seeing here is I can establish a bunch of connection information, and then I can say open session, and I'm going to go to this pet local one that we were looking at before, and I click there, and now I have another session opened up called pet local. And if I click on tables, when I click here on tables, Omnis just did a call to the system tables of the database and determined that there were 5 different tables there, and it sent me back the information on them. If I double click on the table, Omnis goes again to the system table of the server, and it shows me the information about the columns in that table. It actually gives me the tools. I could change the names of columns or change the properties of columns here in my SQL browser, but I typically don't like to do that. Part of what the SQL browser gives you is the ability to do some level of database administration. I can create tables from within the Omnis environment. I can modify tables. The schema class, we'll get into it more later, but it's Omnis's picture of what's on the database. So if I click on SAnimal, I see something that looks a lot like a file format, but it's something called a schema class. But it's basically a map of what's on the server. So here, but this is in the Omnis environment. If I go back down here to my pet database and double click on animal, I'm seeing the server view of the same thing. A handy thing you can do, both with notation or here by drag and drop, I have a table called Red Sox here. Notice in the schema here, I don't have anything called Red Sox. So I can go here and take this and drag it to here. And now here's Red Sox. So if I double click this, it's just copied over and built my Omnis map of what's on the server. So what some people do, and again it depends, in most of my environments it's very controlled. I'm the only developer, or my wife and I are the only developers, and we know that the database and the application are in sync with each other. But sometimes you've got a DBA doing stuff that you don't know. So what you can do is, another thing you can do is on startup, is you can rebuild your schema classes in Omnis to match the server database. So you can, if you wanted to, you can write code to synchronize your application with the database at any point you want to. I'm going to get rid of this now, because we might want it later. But the point is here is there's this drag and drop capability between the SQL Browser, which is really Omnis's window into the server, and the Omnis library itself. Again, these are sort of nice tricks and good to see how it works, but they're not things that I typically do when I'm developing a real application. Let's step through the code and see how we use in a method how we log on to a database server, okay? So if I go back here, oops, never mind that. I go to home. Oops. There we go. And we'll use the Omnis SQL one. I think if I hold down the Option key and click Log On, yes. I just have a little something that says if #Option breakpoint. So I just clicked, just to review what I just did, I selected Omnis SQL in my button, and then clicked on the Log On button. Oops, let's see if I remember how to do this. There we go. So let's see what happens. So I have a task there. I have an object called my common SQL object, and I've instantiated it in a task variable called TV common SQL object. So we can see I've got something called TV common SQL object, and it's this thing called OCommon SQL in my pet library. Are people familiar with object classes and the use of object classes? It's basically, I mean, it's a place to keep common code that I want to use in lots of different places. So I'm calling the logon method in my TV common SQL object here. I'm assuming it works. I'm going to come back here and do other stuff. So if I step in, so here, this TV session, all that is, don't get too confused by it. These different radio buttons control the content of TV session. So this is 1, 2, 3, 4, or something like that. I forget the numbers. Actually, I've got other invisible ones because I think, well, let's see what TV session is. I've clicked on Omnis SQL, and TV session is equal to 7. So, and I just do some tricky thing with hidden radio buttons because I used to have more options and I took some of them away. So my TV session is set to 7. The user clicked and said, I want to log on to Omnis SQL. So here we are. So I'm doing a method called logon omnis v3. First thing I do, now here I'm referencing something called TV Omnis v3 session. This is a task variable called Omnis v3 object, and its subtype is Omnis SQL sess. This appears as a possible subtype because I have the DAM installed in my xcomp folder. So I've basically instantiated in a task variable the Omnis SQL DAM. And if I look at this, if I look at my TV Omnis v3 session and go to its interface manager, I see a whole bunch of methods that come with the Omnis v3 DAM, including something called logon, which requires a host name, a username, a password, and then optionally a session name. I also see a logoff, which doesn't require any parameters. I see other things like commit, clear, other things, some of which we're going to get to today, some of which we're not. I also can see the list of properties associated with this DAM, but we're not going to get into that now either. So the first thing I'm doing is calling the logoff method. So I have no control over this. I can't override it or do anything with it. It just exists. And what it does is it disconnects a session that I have established and then prepares me to establish a new one. So if I step in, it just jumps right over. There's nothing to step into. So here I'm prompting for a user and a password. So I'm going to just set a one-time breakpoint here and say go. And here, like I said, the Omnis SQL doesn't really need or care about an ID and a password. When you connect to an Omnis database with Omnis SQL, there's no ID and a password that it considers or looks at. I still enter one because I put a user stamp in every record that I modify. So if I leave this empty, it looks stupid later when I have nothing there. Okay, so now I didn't press flag false, so now I've got pet here and I've got store here. Here I've got a memory-only file format variable, basically a permanent variable that I put the user into because I use it from all over the place and it's never going to change. So here I use file ops to prompt for the file name because I need a path name in order to connect to the Omnis SQL server, unlike other databases where I need something called a host name, which is a combination of a database name and an address of some kind. For Omnis Studio, I need a path name because it's really a file that I'm connecting to. So I use file ops. So again, I'm going to just set a one-time breakpoint here and say go. I select this. I say open. And now, if we look at this LC path, we see the complete path to the file that I'm connecting to. So this is the important bit right here. Now I'm calling the $logon method in the DAM, in this thing that the Raining Data or Tiger Logic people gave me, and I'm passing three parameters: the path name of the data file, username, password, and I'm passing a fourth parameter, which is the name of my session. I didn't have to do this, but that way I can recognize it later. So if I do a step over, now if I look at, let's see what it shows me here. What I'm looking at here, let me just show you how I got here again. I just do a right-click on this TV Omnis v3 session, which is my task variable associated with my DAM, and select this, and I see all of its properties. I'm just going to do that. Save Windows Setup. So here's my host name, which is my path name. Here's information on if I recently had an error or anything like that. Down here is the version of the DAM. It's Omnis DB 501 DAM. So this is information about this now active session that I've created, this connection between Omnis and the Omnis SQL database. By the way, since I currently have OpenBase connected, if I go to, can I do this here? No, this doesn't show it to me here. Oh, I know what I wanted to do. Did I lose my breakpoint? Rats. Hang on, I'm just going to set a breakpoint so I can get back to here again. Remember, the first thing I do is log off every time and then log on again, so I won't have multiple sessions. What I want to show you is that over here in task variables, I also have an OpenBase task variable. And if we look at that, we can see all the information about my OpenBase session, because I have two sessions that are both open at the same time to two different databases. Not normally what you do, perhaps, but it's perfectly possible to do this. And I have written applications where I've done this. I wrote one application that had to connect to both a network-based, a department-level database, and an institution-level database. So my one Omnis application connected to both, and I was actually able to do SQL calls that to the user looked like I was getting data from two different places in one SQL call. Really, I was doing multiple calls and then merging the data and presenting it to them as one. But you can do lots of nice tricks like that in the Omnis environment.
Can you open up to two same vendor databases, like two oracles?
Yes. Yes, as many as you want, as a matter of fact. Yeah. So we're here now. There are a bunch of properties that you might want to check when you first connect to the database. I dump them into %% variables here just so we can look at them.
What are these %%?
Okay. Oh, a %%, it's just an on-the-fly, it's a shortcut way of making a local variable that when you type it in, as soon as I type in calculate %%, it's created a variable. It's as if I went up here and put in a local variable. And then it goes away as soon as you're quit out of that method because it's a local variable. Some programmers hate it and say it's really bad code and bad habit, and others are lazy like me and use it just for local variables. In this case, it's just to illustrate that I can point and see my native error code, my error code after this logon is 0. There's nothing in native error text because there wasn't any. Error code is kdam, no error. And the difference here, error code and error text is what Omnis reports after some interaction with the DAM. Native error code and native error text is what the database server reports. So different database servers might have very different codes that mean the same thing. If you try and insert something with a duplicate index where duplicates are not allowed, Oracle might give you a negative 4254, and SQL Server might give you an error 525 or something like that. So my native error code and native error text might be different, but the Omnis DAM will return duplicate record, insert failed, something like that. And here I say so the way I ask about the state is I say if TV Omnis v3 session state, meaning the $state property of the task variable that's associated with my Omnis DAM and my Omnis connection, if its state does not equal session state logged on, something terrible has happened, and I give my error message and I quit out. What we get into here, the Omnis a true SQL compliant server gives you a lot of interesting options on how your SQL is handled in terms of when it actually takes effect and when it's saved. You can set your SQL server so that as soon as you send an update command or delete command, instantly that's taken effect. Or you can use a transaction processing mode on a server. So you can say, I'm going to do something called begin a transaction. Then I can send a whole bunch of commands to the server, and then I can commit all those commands, or I can roll back those commands and undo them. So if you have a lot of complicated transactions in some banking program or something, where if any one of them fail, you want to undo all of them, you might use transaction processing. And that's pretty much it. That's how you log on. So, I mean, the more typical application, it opens up, you have a logon window. When they click log on, you don't have lots of different choices for different databases. You just have one. You go through this code and you log on and you have a session that's always there. But people do lots of different things. Sometimes people will open up multiple sessions, one for reading data and one for writing data. And there's ways you can use that to optimize your application more. Or at least you can make your application a little safer, where certain windows use the session that's the read-only session, and only special windows use the sessions that's the read-write session. I tend to not do that, just have one session that's always open and always there, and that's what I use. Let's talk about schema classes and table classes. First, there's two different ways to issue SQL and to communicate in SQL to my server. One is kind of the old style way. I can build a SQL command, select name, first name, last name from people table. And then I can put it into a statement object, and I can send it off to the server, and then I can fetch back the result and put it into variables. But there's some great shortcuts that are built into Studio that will work for 90% of what you can do. And those are schema tables and schema classes and table classes, and they work together. But first, let's talk about the schema class. And we saw already, a schema class is a view in Omnis, or a map in Omnis, of what the database table looks like. Or at least it's what the portion of the database table that I care about looks like. Maybe the database table has a lot more stuff than that. I don't care. But Omnis has given me a way, using this schema class, to build a SQL call on the fly, define a list using this schema class, and pull back the results fast into a window. And we use something called define from SQL class. It's a built-in method that allows me to define a list based on a schema, or sometimes it's a table. We'll talk about schemas now. So I can define a list based on this schema by using the define from SQL class notation. And then I do a select and I do a fetch, and my list is populated with the data from the server. I can include a where clause if I want to filter that result, or I can just bring everything back from the server. What I'm going to do now is very quickly, it's the only time I'll do this, I'm going to use one of their nasty little class wizards to build a window that pulls in the data into a list, just so you can see the very simplest approach to how we can use this define from SQL class notation. So I'm going to say I want to do a window class, and I want to do a SQL form wizard, and we're going to call this wjunk. That's my own notation that means throw this away later. And we're going to do a display grid based on a schema or query class. And I'm going to say next, and it says, okay, what schema do you want to use? And I say, I'll use the animal schema. And it can also say, by the way, which columns do you want to use? And just for fun, I won't include this one, and I won't include this one. No, I won't include this one. Now I say next, and now it says, now wait a minute, you've got 3 different sessions connected to the database. Which one do you want to use? And I'm going to use this Omnis one here. Now it wants to know what color I want it to be, and I just don't care, so I say next, and now I say finish. So it just made this window for me. And let's just close everything else just so we can see it. If I do a Command T, poof, I've got my data. So I didn't have to do much to do this. Did it give me a usable window? Nah, because the wizards make some very generic choices that are never what you'd really want to do. But it's great for illustrating what happens. So let's take a look and see what happens in the construct of this window. And we'll just set a breakpoint right here. And again, we're going to do a Command T. So here we are. The very first thing it does, I've got something called iSQList. It's an instance variable, type list. If I right-click on it now, I see it's empty. If I select it, there's nothing there. But I'm going to say do iSQList dot dollar define from SQL class, and then in quotes the name of the schema. It's going to take this schema and it's going to define my list accordingly. So if I do a step over, now if I look at iSQList, still empty, but now it has my column names. Notice there was another column called, there was some column that I removed, and it Still shows that one. My removal was just in the building of the columns of the window. It has nothing to do with what I'm selecting, which is interesting. So what I've got here is a list that's defined with the columns of my schema. I actually have a lot more than that, because by defining from SQL class, if I right-click on iSQL list and look at Interface Manager, there's all this stuff here. And actually, I'm going to clear my method stack. I want to do it again, because Command T again. Right now, if I right-click on this, there is no Interface Manager. It's an empty list, nothing up my sleeves, there's nothing there. But as soon as I do a step over, now I see Interface Manager, and I see all these methods. I can't yet override these methods, but I see them. And these are all methods associated with a session that's associated with the DAM that I decided to connect to. So the Omnis DAM provides me with all these different methods: a select, an insert, a delete, a do delete, lots of things we're going to learn about later if we have time. All of a sudden, these are available to me, and they're bound to this list. So not only did I define the list based on this schema, I've bound this list to my DAM and given this list a whole bunch of methods that I can use to interact with my SQL server. So long as I define my SQL list from a schema, I can't override any of these methods. The reason we use table classes, which I'm going to get to 5 minutes from now, is because with a table class, all of a sudden you can override the methods, and you have complete access. If you want to do an insert, but you know that anytime I insert to the animal table, I first need to do something else, then I would take the animal table class, and I can override the $insert method there. I can do my own stuff, and then I can do inherited, and it goes ahead and does the built-in insert. So the schema class gives me all of these methods that allow me to communicate with the server, but I can't override them. When you add to the mix a table class, it gives us, the programmers, access to these methods. Really what's happened under the surface when I define from SQL with a schema class, I've really built an instance of a table class that I have no access to. So I can't do anything with it. But as soon as in a real programming environment, you pretty much always use table classes associated with your schema classes, because the table classes are very powerful because you can add your own methods, you can override methods, you can do all sorts of great things. But for now, we're just seeing the very simplest version of this. The next thing I'm doing here is I'm binding this list to a session object, which I need in order to actually communicate this SQL to the server. I have to do this session object assign, and here it's explicitly saying this is a session object associated with the OM3 session that I created in this group of sessions in root. Notice $root $sessions is notations telling me there's a group of sessions associated with root, and one of them is named OM3. How does it know? Because I selected it in that interface. And again, you're not too likely to hard code your session name in every window everywhere, but the wizard hard codes your session name in the window. So here I'm associating my list with a session object, and now I can do a select. When I do a select, what I'm doing is sending a message up to the server, and I get back a little feedback on how that select works, but I don't get the data back yet. I've basically sent a message to the server saying, I'm considering asking you to give me this set of data. The server goes ahead and selects it, keeps it in memory on the server, sends me back some information, how many rows it found, whether or not my syntax was correct, things like that. But if I do a step over here, there's still nothing in SQL list. I then need to fetch the data in order to bring it back into the Omnis environment. So it's a two parts to this here. You first issue a select to the server, and then you do a fetch to actually get the data back. So and then in my parameter, I can give it a number, like just give me 1 or 2 or 3, or I can do kfetchAll. Notice when I hold my mouse over kfetchAll, it actually, it's just a Omnis constant that's, I don't know,
100 million?
100 million or a billion, more than 100 million, I think. But it's too many zeros to count. More than you'd ever want. So now when I step over, now I see my data here. So this is kind of the simplest form of using a schema and building a session object. We're going to kind of jump ahead now. So if I do go, and there's my data. A table class, if we look at the properties of a schema class, first of all, the most interesting properties here is something called server table name. That's the name of the table or view on the server to which the schema corresponds. So my schema named is SAnimal, just because I start all my schemas with a lowercase s, so I recognize them. But the server table name is animal. So this schema is associated and maps to the animal table on the server. It works in my application against multiple servers because they all have tables named animal that have the same columns and the same properties. And those are really the only things that are important about the schema in terms of its properties. Its name and that it's bound to this table named animal on the server. Now we have something called a table class. I've got something called tAnimal. And if we look at tAnimal's properties, we can see that it has something called SQL class name, the name of the query or schema which the table uses. So I've got my schema class, which is mapped to my server table, and now I've got a table class which I bind to my schema. And the reason I do this is now when I do a define from SQL class and I use the table class name, I get the same results. My list will have all those methods, but all of a sudden now in the table class I can override those methods. I can first of all see those methods, I can open up the table class and see them, and I can override them. And even more important than that is I can have a superclass, a base class associated with all my table classes where I can have common code that's used by any table class. And for instance, if there's something I always want to do on an insert, such as maybe in the Omnis environment, first grab a unique key, or first grab a timestamp maybe, so I can insert always with the timestamp, I can trap that in the $insert method at the table class or at the superclass level. So every insert first gets a timestamp and then does an insert to the database, and the time is included as a column in the database. And I can do the same thing for my $update method. Anytime I modify data on the server, I can trap in a $update method and do whatever I need to do before executing the actual method against the server. We're going to take a look at this window, which it started a long time ago as a wizard, but I modified it and changed it to things that I liked a little more and the way I like to do it better to become sort of a finished thing. And basically what this window does, when I click on species, and we'll go back to Omnis SQL, I can next through, and I see them all. They're in alphabetical order. I can do a previous. So let's see what this window does. Okay, the very first thing I do, I've got a row variable called iSQLRow, and I do a define from SQL class. I could have said quote tspecies end quotes. That's an acceptable syntax, is to inside quotes have the name of either a table class or a schema class. However, if you do that and you type it wrong, it'll ignore you, it'll accept it. Whereas if I do $tables.tspecies, I'll get an error if I type it wrong, I think. So for some reason or another, I like this syntax better. So again, if I look at iSQLRow now, there's no interface manager, and when I look at it, there's nothing there. I'm going to step over it And now when I look at it, I see an interface manager. I see all sorts of built-in methods, but look down here, I also see all sorts of methods that I've overridden for some reason, and they're all available to me. Now we're going to clear our method stack, close this, close you again, and this time, if this was a schema class and I did a step in, nothing would happen. It would just do it and we'd be gone, because there's nothing to step into when you define something with a schema class. But when I use a table class, when I step in, it's going to bring me to the construct of my table class, and if my individual table class doesn't have a construct, it'll bring me to the construct of the superclass that's associated with my table class. And my superclass is called tBase. So if I do a step in, it's taken me to $construct of tBase. And I forgot to show you, but if we looked at the properties of my table, we would have seen its superclass is tBase. So, and I say right here, so this is where you're going to start to see lots of comments in my code. This construct gets executed on defined from SQL class if my class base table is tBase. That's how we got here. So, what I do, remember in that window built by the wizard, there was a line of code that associated a session object. We have to do that, but I can do that in the construct of my table base class, and that's the only place I have to do it. And the reason I'm not familiar with this code is because I did it once here 8 years ago, and I've never looked back since. You don't have to look at it. So I've got a slightly complicated thing because this application has that interface on the front window where the radio button says which session we're associated with, whether I want to be OpenBase or Omnis or whatever. So what I'm doing is I'm calling this method that I wrote called getSession, which just returns, let's do a step over first. It returns tvOmnis v3 session. It returns the name of the task variable associated with my Omnis DAM. And how did it get that? Let's go back here and just step through it again. Do a step to get session. Pretty boring and pretty obvious. I'm just doing a case statement against my TV session to give the name of the task variable that I know is bound to my Omnis session. And now I do cinst session object assign and then the name of the session. $cinst, I'm in the construct of my table class, or my table superclass in this case, and I got here with the defined from SQL class. $cinst in this case refers to the row variable or the list variable that I did my defined from SQL class against. So I did an IV SQL row $dollar defined from SQL class. That brought me here. Cinst refers to that row variable back in the window that I called into here from. And you'll see anywhere in this table base class or any individual table class, you can use $cinst if you want to act upon the row or list variable that you're working with. So I'm binding a session, a new session object assigned to cinst, which is my row variable. And here I'm just showing a fancy, this is a one-step way of doing it because I can, instead of assigning the name of the session, I can assign this call to an object, and really it evaluates, it returns the session name here and then puts it in the $sign. So that's just fancier notation for the same thing. Notice what I just did there. Even with this one-liner method, if you do a step over this, it actually steps into this method. If you have a method embedded inside another, inside a do statement, it'll execute and go into that method. Briefly, we'll touch on session pools later, so I'm going to skip over that for now. So I'm doing some interesting things here. Cinst.sessionObject is this session that we just associated with our row variable that we bound to the table class and schema class. I'm setting a reference to it because that's going to allow me to look at it. So if right now, if I look at this, there's nothing here. But if I do a step in, now if I look at IV session ref over here, I see all the properties associated with the session. Hang on a second, sorry about that. So I've just created this new, oh, I'm sorry, I haven't done a statement yet. The session object was bound to, as soon as I did my define from SQL class, when I gave it that task variable name, which was the Omnis v3 dam, it built a session object and associated it with this cinst, with this row variable, and that's what I'm looking at here. So the session object shows me information about my connection to the database, what my transaction mode is, what my version of my dam is, what my connection status is, which is case session state logged on. Kind of the more interesting one is my statement object, which I created here. And if I step over this and look at statement ref, here's all the properties associated with my statement. No errors have been reported. I haven't done anything yet. My row count, rows affected, rows fetched, everything is clear. I haven't done anything with this statement yet. I've just created it so it's available for me to send SQL back and forth using my statement. The statement is kind of the vehicle that your SQL goes through the session to get to the database and back. And I also set a reference to cinst.ref. And if I do that, now when I look at this, it's really a reference to iSQL row back in my window. And if I look at iSQL row, it's been defined because remember, as soon as we did our define from SQL class, that row or list variable got its column names. But there's nothing in it yet because I haven't yet done a select or a fetch. So this is all just in the construct. What I've done in the construct in my table superclass is I've instantiated a statement object and associated it with my session object and with this row variable or list variable that I've done the define from SQL class against. That's all you need to do in order to make this work as a V3 dam instead of a V2 dam. So really, the two lines of codes that you care about to make it work for V3 dams is this get session, because this session object assign, associating the session with my row or list variable, and this one is it builds a statement. Where's my statement? And then my statement associating that with it. So that's all the code I needed in my construct of my table superclass, and then all of a sudden my V3 dams worked. I didn't have to do anything else. For any data I/O where you're using define from SQL class, there's other things you have to do if you're building your own SQL and you want to send it up and return it back. So now I calculate, I'm back in my window now. Right, I'm in the construct of my window. All I've done so far is this one line in my window defined from SQL class, but we then stepped through my table superclass. So now I calculate IV order as order by species name. And I do a private method in this window called fetch. And I say do iSQL.$fetch 1. I'm using the built-in Omnis fetch command associated with my SQL row that I used to define from SQL class, so this is meaningful now. This is going to send a fetch up to the database to pull back a record. What's confusing is I haven't done a select yet. So this is actually going to fail right here, and you'll understand once we get through the whole process why it's here, what happens. So I'm going to just do a step over this time, and my status is kfetch error. And my fetch failed because I just tried to fetch a record, but I haven't done a select yet. So how could I possibly fetch? And it has to do with the way this particular window works, where I'm doing a select and then doing a bunch of fetches, and I'm calling this common code to do it. It'll make more sense when we get into it later. So my fetch failed. We don't really understand why yet. I didn't ask to do a previous, I asked to do a next. So now it's saying if my fetch failed, I better do a select. And what I'm going to do in this select is select on the server. I'm going to send my select statement to the server. It's calling a private method called select. What I'm doing here is I'm doing a $select with my row variable, and I'm concatenating a where clause where I have nothing there, and ivy order, which says order by species name. So I'm doing a select. It's bound to a row variable, so I can't possibly pull back multiple lines, right? Because a row variable is no place to hold multiple lines. It can only hold one. But that doesn't even matter here. I'm issuing a select of all rows in the database ordered this way. But a select doesn't pull any data back to me. A select builds a table in memory on the server, a select table, where it's holding the data. So I do this select, and I'm going to step in. I don't know if I override this or not. Oh, I do. I'm illustrating here. Notice I'm in my tspecies class. I'm in my table class for species, just illustrating that I could put something here if I wanted. Of course, if I have a $select here and I want it to work, I then need to do inherited. So it goes up to my superclass and from there onto the built-in method. So if I do a step, here I'm now in the $select in my base class. All I do here is I'm looking to see if there's anything in species name. And there's an exclamation point there, which was some bug fix for Oracle. Now do default says do the actual $select that's associated with the DAM. As soon as I say do default, I'm going to the DAM to do my select. I'm passing my order by clause. And as soon as I do this, now there's this select table on my server. My server has the data ready for me to ask for it, but I haven't asked yet. We're ignoring this stuff for now. We're ignoring this for now. And now I do an iSQL fetch again. I did one up here, but I'm doing one again here. And there's a really good reason why I did one up there, but I can't remember it yet. Oh, I know why. A second. Right. So now I'm doing a $fetch, returning a single row. Because right now iSQL still doesn't have anything in it. I've done the select, but I haven't done the fetch yet. So I do a step in, and this time I didn't override $fetch in my individual table class, but I did override it in my superclass, just for the fun of doing it. I step over here. By the way, I'm in my superclass. Remember way back when we set a reference to $cinst so we could look at it while we're in the superclass? And it should be up here. Here's my ivcinst.ref. I'm in my superclass, but if I do a right mouse on this now, shows iSQL row, and I go there, and now I've got data there because my fetch returned successfully. So as soon as that happened, I'm still in my superclass, but I can, by looking at $cinst, I can see my row variable and I can see my data. Now I do a step, and now I say if my status is fetch finished or fetch error, I'm going to bail out, close the top window. But it's not. My status is kfetch OK. I had a successful fetch. And step in. In 5 minutes, I'm going to tell you why I moved iSQL row into iOld row, but I'm not going to tell you quite yet. And step, and now we're still in the construct of my window. This is where we got, but there's nothing else here. So now when I do a step, and I'll just do a go, and here we are. We opened our window, went to construct, we tried to do a fetch, there was nothing there yet, so we then did a select, building on the server my select table of everything, then we fetched the first record back into here. Right? That's what's happened so far. So what I'm going to do next is take the Z out of Beaver, because we all know you don't spell Beaver with a Z. And now I'm going to click on my Update button. So again, hold on the Option, and I did a breakpoint there. I have a whole section that there's no way we're going to get to tonight on optimistic versus pessimistic locking. And if anybody really wants to know at the very end, you can ask me to talk to you about it. But this all has to do with, I've been talking for a long time, what if somebody else updated the Beaver record while I was talking? That would be a bad thing, because they might have updated a different data element and I'm just changing the spelling of Beaver. What's going to happen? Will my update blow away their update? So what I actually do is I check the timestamp. I have the timestamp of when I fetched Beaver from the server, right? And I'm going to check on the database to see if the timestamp that's up there in the database is the same as me. If it's the same, nobody else has changed it. If it's different, somebody else has changed it, and I shouldn't be allowed to change it. I should get a warning saying, you're talking too much, you took too long, somebody else has changed this, you have to fetch it again. So I'm not going to look at that now, but that's kind of what I'm doing there. So here's my syntax. And there's lots of things we can do. This isn't getting saved, which is very sad. $update is another built-in method which I can override if I want to, and we're going to see how I do override it. It has one parameter. I'm $update against iSQL row. iSQL row has my change in it. It's got Beaver spelled correctly. Notice old row still has Beaver set incorrectly. What Omnis is going to know how to do is it's going to build an update statement telling me it knows that species ID is my unique key. So it's going to say, update the table, set the values to the ones that are in iSQL row where the species ID is 105, which it gets from the old row. So even if I change the unique key, which is a weird thing to do, it knows how to update it from the old row, which doesn't change. It uses the old information to build the where clause of the update statement so it can make the change. That makes sense? So as soon as I step over this, good. We stepped into this, which is what I really meant to do, because this is important. So in my table superclass, I have an override to $update. And that's because I want to have a timestamp on every record saying the time of the update. If I was just running against an Oracle database, I wouldn't need to do anything on the Omnis side to get the time, because Oracle has a built-in function that I can embed to automatically put a new timestamp on a column. And OpenBase has another way of doing it that's different. And so different database servers might have nice ways of giving you a timestamp. However, because I wanted this to work with OmniSQL and I wanted it to work with multiple servers, what I'm going to do instead is I'm in the user just asked to do an update, but I haven't done it yet because I'm in my superclass at the $update method, but I haven't yet done do default. First, I'm going to do something called get update values. Right now, if we look at cins.ref, remember this is pointing to our row variable, we see that this says Beaver, that's the correct spelling. This says species ID, which is fine, I haven't changed that. There's nothing in last user, and the last time is 1948, which was 2 hours ago, right? So I have a method called getUpdateValues in my table superclass. First thing I do, this should look familiar because I'm calling this method called $time that we looked at before, but what I'm passing in is $cinst last time. And I'm counting on the fact that all of the thousands of programmers who work on this application all know that every table in my environment has a column named last time in it. And therefore, I know there's something called last time in $CINST, which is my row variable. And right now, if we look here, last time is 1948.50. But as soon as I step over this, now last time better be different. It is. It's 2134.05. I haven't updated the database yet. I just populated the column in my row variable that I'm about to send to the database. And the other thing I do, remember we put this, our username of pet, into this memory-only file format. I'm putting that into the last user column. So now when I step over this, and now when I look at CINST ref, whoops. Now I see I've got a last user of pet and a last time of 2134.05. We're done with our get update values. Now when I do default, it's going to send my iSQL row, my CINST, and it's going to send that old row, and it's going to make all the changes. It's going to build, update SQL statement, and it's going to change it based on the unique key. So if I do a go from here and come back to here, we now see pet here, and we see my new timestamp.